So welcome back, chat. Real quickly, a couple things. Gosh, I'm just struggling. Centripetal acceleration. What direction to go? Center of the circle. It doesn't make sense to say in, out, up, down, all that stuff, right? Okay. How do you find centripetal acceleration? And if you guys don't have these on your worksheets, on the very top left or in the top right in that box, there are a couple things you probably should have. What's centripetal acceleration? And how does one find it? Louder, Kalisha, because I saw the words, I think. Okay, so it's a center-seeking acceleration. I'm good with that. What's the equation of it? Sean? V squared over r. What's V? What's r? Radius. Okay, easy. If you want to find the net force acting on a uniform or an object in uniform circular motion, Newton hooks it up. It's mass times what? And in a gosh darn it, not that big of a deal. In a center-seeking situation, what's that acceleration called? It's not just acceleration. Centripetal. Now, the only other thing that we didn't hit yesterday in the video is if you're trying to draw a motion diagram for this, it can be a challenge because where's your axes is a kind of hard thing to make sense of. I'm going to be honest. This is one of the times where I often rely on pictures more than the free body diagrams. If you want to draw the free body diagrams, we can, but it's strange. Instead of X and Y, because we're constantly changing where we are along a circle, we use different labels for our axes. We can use C for centripetal, which just goes towards the center. So one axis would be just thought of as toward the center of the circle, and the other one is the tangent. It's a weird thing to do. I honestly don't think that there's a ton of additional knowledge that we get from building these free body diagrams for these situations, but a picture is super duper helpful. Like every time the picture is really helpful. Okay, so moving on from that, I think we should do a couple problems and then start getting set up and measuring some data. Cool. All right, question 1 yesterday, and I don't have the worksheet in front of me. I thought I had an extra one, but, oh, do I? Nope, I was wrong. Question 1, that was Jay swinging the fishing line, right? Okay, felt all right, felt terrible. Okay, after question 1, I asked you guys to do what? Go to question 3. Question 3, can anybody hook it up? It's velocity initially the velocity is 8.8. Okay, were you guys able to work through number 3? Riley, what'd you get? What's the centripetal acceleration? 77.34. Can you tell me how you got it? So double check this for me. Do 8.8 squared? Because I have a feeling you forgot to divide by 25. I think you did. I could be wrong. Or anybody with a calculator handy, do me a favor. 8.8 squared divided by 25. 3.1? Okay, definitely what happened, Riley. That's an easy mistake to fix. Okay, 3.1 meters per second squared on number 3. Okay, or do we need to look through it? So that's a terrible way to ask a question because when somebody answers yes, I have no idea what it means. Would anybody like to work through number 3 real quick? Okay, I'm fine with that. If somebody's being shy, stop it, just so you know. Let's do a harder one. Let's do one harder one, and we'll do one harder one together. I'll have you guys do one harder one on your own, and then we should have hopefully 10 or 15 minutes to go get set up to just launch either today or tomorrow. Yes, the agent on, I don't have the context in front of me. Can I steal this for 1 second? On number 3, sorry. Ooh, so here we are, we're running around a track. What's pushing somebody towards the center? It's not gravity because there's not a big star at the center of this track, I imagine. As I'm turning, and any time that you're turning, that curve is realistically part of a big circle. It's not always a perfect circle that you're turning, obviously, but any curve that I make, I can find a circle of that curve, even if it keeps changing. So check it out. With this, gosh, I must have, here we go. It's kind of like a string, right? Okay, what's the agent right now? What's causing the force that's pulling this thing toward the center of the circle? It's not, I'm kind of. It's me, I'm the agent, right? But it's actually the string. I'm exerting force on the string, and the string is what's pulling that toward it, right? Okay, ours planet. If you buy into, all of astronomy and physics, what pulls our planet towards the center of our solar system? The gravity is what does it. The agent that causes gravity is the sun, right? So you were right, whoever said me, because, yeah, the string does it, but I'm the agent that causes the force in the string in the end. What about as I'm turning right now? Here I go. I just turned. Something happened, so it's kind of me, but there's a better idea down here. I'm wearing shoes, and we don't walk around on, like, slippery, icy substances all the time. What's the point of my shoe? One, it protects my feet, but even if the surface were kind of slippery, I think I'd still be able to walk in a turn. Say it again? Maybe. I don't quite get how that applies here, but I like where your head's at. Friction. It's the friction between me that's causing that turn to happen, right? So friction is pushing me inside toward the circle. Now, good question. Great follow-up. Okay, looking at that, I'm going to go ahead and find physics stuff at some point in time. It'll happen. And we're going to look at problem number 2 together. So I want you guys to read through. I'm going to give you a little head start. And these problems honestly don't really get any harder. I was thinking ahead a section. I want you guys to look at number 2. Try to list out your knowns and your unknowns as I'm getting everything set up so I can see the context too. Picture, if you need to. So I'll list down the knowns here in a second. Here is a perfect circle. Cool, it's beautiful. What could I know, or what do I know about this circle? I know velocity of the circle. How would you have me draw that on the circle? Okay. Love it. So, yep, I agree. So tangent to the circle. I'm good with that. Okay, anything else that I know? I know the radius of the circle, and I'm just going to stick everything red. There it is, and it's 56, right? And it's 56 meters. Anything else? Not really, right? Now, the only other thing that I do know is that if I didn't have some force causing centripetal force on me, I would just fly off and go in a straight line like that velocity is telling me. I'm going to draw it elsewhere, just randomly. There is a force here. That's not very center-seeking. There is a force at every point on this circle that is pushing exactly towards the middle. And this is our force of centripetal acceleration, or the force of the centripetal force, I'm sorry. Okay, so looking at it. We have this picture, and this is, I think, all that we truly need. What are my formal knowns? Totally, hook it up. Give me one thing I know. I know the velocity is 22 meters per second. Cool. Riley, something else. I know the radius r is 56, meters. Cool, I'm good with it. Anything else? That's it, right? So all of a sudden, this problem, I don't think the math is super hard, but the ability to recall things that have been a while, because we had, forever off for Christmas break, or holiday break, whatever you want to call it. What are we actually trying to find? I'm trying to find the coefficient of static, that should say kinetic. I'm trying to find the coefficient of friction, though, because whether it's static or kinetic isn't going to wind up mattering for our calculations. I need to find this. Okay, my bad on calling it static. That was just a hiccup in my head. If you want to cross it out and call it kinetic because we're moving, that's more appropriate, but same calculation. Anything else that I need to be able to find it? How on earth, where's mu k, or the coefficient of friction, come from, and how is it related to forces? So here's a fun point. Love what I'm seeing over there, Barsega. I need some expression that relates friction to all of this and forces. So if you don't remember it off the top of your head, which is kind of what I expect, that's okay. Find it. You guys have notes and notes and notes on friction. Find me how this ties into anything related to force so that we can get there. I know that you'd said it a second ago because you raised some new concerns, which is awesome. What is the force of friction? So the coefficient of kinetic friction, mu sub k, and the normal force. Okay, Sean had issues with this, and not necessarily an issue, but an immediate follow-up question. What's the possible issue that we're going to run into trying to use that? Too many people at once. Go ahead. Sorry. Gosh, we don't have the numbers for it. What's the normal force? It's opposite of gravity, right? Which, to find that, you need to know the force of gravity, which you need a mass. Anybody know how much this person weighs? Yeah, me neither. Bummer. That's all right. We'll keep it going. Okay. Now, the force of friction in this situation, what direction does it have to point to keep us going in a circle? Towards the middle, which means that's a centripetal force that we're looking at due to friction. To find a centripetal force, you need mass, which we're still in an issue there. But we also need something else. Mass times something is how we get force. One more time. Gravity if we're working up and down, absolutely. Newton's second law says mass times acceleration, says Fern. What sort of acceleration if we're going towards the center of a circle? Centripetal. So check it out. We need to find a sub c as well. Like we need our centripetal acceleration. I know there's some other pieces that seem like we don't have enough, but when we start playing around with it, I think we'll figure out it'll work out. Okay. Based on just that, I think I'm good to roll with this. Can we find centripetal acceleration with what we have? How? Okay, so you take the square velocity and divide it by r. 22 squared, I have no idea. You could probably work it out, but I think your calculators can do it a lot faster than me. Centripetal acceleration is 22 squared divided by 56. One more time.
I got 8.64.
I agree with you. 8.64 meters per second squared. I'm going to star that. We're not done, but we're going to use that. Nothing crazy has happened. We have found the centripetal acceleration of this object, or this person, the car, I guess. Okay. Now, from here, we are going to feel like we have an issue, but I always advocate for don't plug in numbers till the very end. And this is one of those situations where we're not going to plug in numbers because we literally don't have them. But let's start thinking about what we're actually trying to find. We're trying to find the force, or the kinetic friction coefficient, that's going to come from this force. Now, even though the force is due to friction, do you all agree that it must be center seeking? So I'm not going to call it F of friction. I could call it F sub c for centripetal, but I'm just going to call it F net, just as normal. So the net force I know is going towards the center of the circle. Easy. And how do you find it? M times acceleration, right? Okay, we have this expression. Now, for now, I'm good with this because this looks like Newton's law. What did we say it was that was causing us to accelerate, just only change the direction, not speed, towards the center of the circle? So it's centripetal acceleration, but what's the agent of that centripetal force? Friction. Okay, I know that the net force is just going to be the friction, right? Which means if I wanted to, I could write F sub Fk right here instead. Now, I will take that step just in case we need to. The only force acting on this thing right now is friction because we're not looking up and down. I know that this could be changed here. Instead of just saying the net force, we're just being more specific. It's the force due to friction that's causing this centripetal acceleration. Everybody's still okay? Man, what's this though? This doesn't really do it for us because we need mu k, but mu k is hiding in here. What can I replace the force of kinetic friction with? Mu k times the normal force. Now, you kind of have to trust the process. And it's going to happen a lot in physics, in upper level math, where maybe it doesn't seem like you're making a lot of headway, but all of a sudden stuff pops out and you're done. I can now solve for mu k, right? Kind of. If I wanted to just solve for mu k as is, I would have to just simply do what? without a number, just to set an equation that says mu sub k equals something, I think I could just divide both sides by some value.
Alright, but first you'll have to unlock your device.
I don't know what on earth I possibly said that made it think I was talking to it. I have a suspicion. We have a Google thing at home, and Mrs. Holloway's home with Zeke today, and my guess is she just asked it to do something, and for some reason my phone thinks, I don't know, it's odd. I don't quite get it. Can we divide both sides by fn? Like that's all I'm looking for. But that doesn't really do anything because we don't know fn, right? Like that doesn't help. Okay, however, I think it probably will help. But we're just gonna take one more little step before we do any movement. How do you find the normal force of something? Rafa said a couple minutes ago that it's the opposite of gravity, the force of gravity. How would you find the force of gravity of something? mg, right? So the opposite of that is the normal force. Now, typically, we have to think about that weird positive and negative thing. Can we all agree that for this situation, we're just going to think the normal force is positive in the up direction, even though it's not really a three-dimensional problem? So let's do that. Fn, I'm going to use this little thing, this yellow. I'm going to take the normal force, and I know that that's just mass times gravity. That is the normal force. That's how you calculate it. And nothing else has changed. We're just doing a little bit of substitution stuff. So I get mu k times mg is now equal to mass times the acceleration. We're just doing some substitutions here. Nothing crazy. It might not feel natural the first time that we do it, but all of this is stuff that we've covered. At this point in time, any concern that I have about mass has been alleviated. Why? When I divide the left side by mass and I divide the right side by mass, they're both gone. I don't need the mass in this problem. Doesn't wind up calculating in. So let's do just that. I'm going to divide this side by mass times gravity, and I'm going to divide this side by mass times gravity. Cha-cha-cha-cha, they gone, and cha-cha, they gone. All of a sudden, I think that we have, after a bit of work, a super duper easy way to calculate this out. We've just determined, and I hope that you're convinced of this as well, that the coefficient of friction is just your centripetal acceleration divided by gravity. Do we know those numbers? Plug and chug, and let's get a value here. So 8.64 divided by 9.8, right? And what do we get? .88? Cool, cool. Now I know that a coefficient of friction of 0 is like literally no traction, so this is reasonable to me. All we need is a context. What minimum coefficient? So I guess I'm not going to make us write the contextual sentence here. The coefficient of friction between the tires and the road has to be at least what? 0.88. And double check, did you get 0.88 or did you get 88? Okay, cool. Awesome. The coefficient of friction between the tires and the road is this. Minimum. Has to be. Cool. There's a little bit of stuff like from before that we have to implement in here, but overall this problem doesn't add anything too crazy. Cool. I want y'all to try number 4, I think. Right, let me double check. Can I look at your sheet real quick? I just want to make sure I'm not giving you one that's way different. I want you guys to try number 4. Cool. I'm going to give you a couple minutes to work it. I'll kind of walk around a little bit and check stuff out. Feel free to chat it out. Remember, I don't want you to be concerned about being wrong. I want you to be concerned about not trying.
So just use 49. Let's just keep it here. So 49.
It's very good. It's so acceleration.
Yeah.
How fast is the plane going? 201. If you're doing this one, I can check this one too. Or are you doing it? Okay, so you're all, so this means times 10 to the negative 4. I don't think that's quite right. But just so you know, like, this is just going to be a repetitive thing. You know, always show your stuff, because, like, I can't really tell for sure what happened here. I'll tell you, I don't like that number necessarily.
I don't know.
What do you know? You know your velocity? Anything else you know?
Now the minimum, or we kind of know the centrifugal acceleration.
Do you kind of know it, or do they give it to you exactly as a number? So I would, so you're, yes, and that's my bad. I was,
Use 5 point.
I would use 5. So that's easy. We're looking here, right? So we know velocity. Velocity is 201 meters per second. I ran down what it is here. And we turn the smallest radius. So you say this doesn't make sense. Why? Why do you think this number doesn't make sense? So if you were a plane, let's say I'm a plane, I'm going 200 meters per second. Super duper fast. How tight of a circle do you think I can safely make? Like, in the grand scheme of stuff, flying is
That's what I was trying to do.
probably not, especially since it only takes you like a very short amount of time to go. Like it takes you what, 20 seconds? It's like you're going so fast. That never feels right. Love it. Yeah. Just plug and chug. You got it.
What is AC?
So our plane falls us apart apparently if we go above this. I don't know if that's true or not, but that's what that's what I'm going to claim. Okay, I know this and I know V, right? Now, with this, 200 meters. Oh, weird. Excuse me. 200 meters per second. Slow or fast? It's super fast. It's like an airplane fast. Now, when we plug this in, we know these two values. We're trying to find what? The radius r. Is there a way to relate centripetal acceleration, velocity, and radius? For sure. Acceleration is equal to v squared over r, right? Do I know this one? Do I know this one? Can I solve for this one? Yeah, boom. Now, I'm always, okay, I'm like 90% of the time going to do this first. I can get this calculation without everything except plugging it in pretty quickly. That's 201 squared over 5, and we're going to get a big number. So here we go. Velocity is 201. We'll square it. And we'll divide it by 5 meters per second squared. And gosh, I can't do that in my head. But 8,000 something? So I didn't do any of that in my head. I saw Sean's answer. I just couldn't remember it. What is it? R is 8. Okay. This seems like a big number. But let's just think about the context. If you're in a plane and you're like full speed, 200 meters per second, that's fast. If you turn and you're already going that fast, if it takes you 30 seconds to turn, just think about how far you would have had to have traveled. 30 seconds at 200 meters per second, that's what, 6 kilometers? That is a huge distance. But we're going really fast, so it makes sense. Is 8,000 meters or 8 kilometers reasonable if we're going that fast? Yeah, this answer makes total sense. Our circle, or the radius. The radius is at least, because that's this number or larger, at least 8, I'm going to say 8 kilometers, because we're close enough that I'm just going to call it that. If you give me 8 kilometers as an answer on a problem like this, I'll take it. If you give me 8,080 meters, I'll take it. Either one. The number's big, but in the context, it makes complete sense. Cool. All right. That took longer than I was expecting it to. We have 7 minutes. I don't think 7 minutes is enough time to launch and do all that stuff. So here's the options. If you are somebody who is still gluing up or doing any changes to your device the other day, I want you to go to the lab. I'll open it up and prop the door open. I want you to check on it, make sure that you don't have to glue anything else up or change anything else today. First thing Monday morning, we are going to do launching and stuff, which means the remaining time, if you don't have anything to do over there, what do you think I might have you do? Sorry? Oh, worksheet. Awesome. Cool. If you need to pop over to the lab, do so. Work on stuff. I'm good with it. If you don't, I'm good with it. Just work on these problems for a couple minutes.
I was asleep. Is this the dagger?
I'm gonna slap you.
Okay. Do you have your sheet? Okay. Bring it to me at any of the other times on the day. Miss O'Malley was psyched about you guys in free talk yesterday, just so you guys know.
Really? We're struggling.
That's okay. Struggle's good. We'll go through stuff. I think she misunderstood a little bit. Cause you guys went over all the answers, right?
No.
Oh, good. Perfect.
She like
We
checked
just went
it
every
through,
time.
like, every time we just.
Oh,
went.
fantastic. Cool. Never mind then. Yeah, we will clear it up today, and then I don't think we're gonna move to a new section today, and that's completely fine with me. Cool. Yeah, she was psyched about it. Said you guys were great, worked hard. There was some confusion, and many were hung up on number 23. Nobody's close to finishing, but they tried with a big old smiley face. Good with it. It was a 2-day lesson that could be 1 or 2 days, just depending. So as I'm setting up launch stuff over the weekend, anybody confident or feel confident enough that we need to go elsewhere to launch stuff, or is the lab and classroom big enough? Nobody's gonna launch like over the school or anything with your stuff? Cool. You guys, I always just interrupt you guys, but I just want to talk about stuff, but I'll let you work next time. If you divided it, it would be fine. Yes, sir. It's so it's looking what's the centrifugal force is really what it is, but it's just your arm is the cause of the centrifugal force. So something annoying that's going on, before break I did a big purchase order.